Magnetic field due to a current through a circular wire. We have so far observed the pattern of the magnetic field lines produced around a circuit carrying straight wire. Suppose this straight wire is bent in the form of a circular loop and a current is passing through it. How would the magnetic field lines look like? We know that the magnetic field produced by a current carrying straight wire depends inversely on distance from it. Magnetic field produced by a circuit carrying straight wires depends inversely on the distance from it. Similarly, at every point of a current carrying circular loop, the concentric circles representing the magnetic field around it would become larger and larger as we move away from the wire. By the time we reach at the center, the circular loop is arcs of these big circles would appear as a straight line. Every point of wire carrying current would give rise to the magnetic field appearing as straight lines at the center of the loop. By applying the right hand rule, it is easy to check that every section of the wire contribute the magnetic field line in the same direction within the loop. Figure number 12.8 shown magnetic field lines of the field produced by a current carrying circular loop. We know the magnetic field produced by a current carrying wire at a given point depends directly on the current passing through it. Therefore, if there is a circular coil having n turns, and circular coil में कितने n turns हैं, the field produced is n times as larger as that produced by a single turn. This is because the current is each circular turn has the same direction and the field due to each turn then just add up. सारे add होंगे ना, जितने ज़्यादा turns उतना ज़्यादा उसमें current होगा. Okay. Though the magnetic field lines the magnitude of field produced by current carrying circular loop at its center is directly proportional to the current passing through the circular loop and the inversely proportional of the radius of the circular loop. And another thing, the strength of magnetic field produced by the circular coil carrying current is directly proportional to both number of turns and current. Directly proportional to number of turns and current, but inversely proportional to the radius. Thus, the strength of magnetic field produced by the current carrying circular coil can be increased. कब increased होगी? By increasing the number of turns of wire in the coil, by the increasing the current flowing through the coil, and third one, decreasing the radius of the coil. Okay, then magnetic field due to a current in a solenoid. A coil of many circular turns of insulated copper wire wrapped closely in the shape of a cylinder is called solenoid. सोलेनॉइड की आप एक और डिफाइन इजीली लिख सकते हैं. द सोलेनॉइड इज अ लॉन्ग कॉइल कंटेनिंग अ लार्ज नंबर ऑफ closed turns of insulated copper wire. The pattern of the magnetic field lines around the current carrying solenoid is shown in figure 12.10. Compare the pattern of the field with the magnetic field around a bar magnet. They look similar. In fact, one end of the solenoid behaves as a magnetic north pole, while the other behaves as a south pole. The field lines inside the solenoid are in the form of parallel straight lines. This indicates that the magnetic field is the same at all points inside the solenoid. That is, the field is uniform inside the solenoid. A strong magnetic field produced inside a solenoid can be used to magnetize a piece of magnetic material like soft iron when placed inside the coil. The magnet so formed is called an electromagnet. It is a temporary magnet. Okay, its magnetism is only for the duration of current passing through it. So the magnetism of the electromagnet can be switched on or switched off as desired. Okay, but electromagnet can produce very strong magnetic field compared to bar magnet or permanent magnet. Okay, the strength of magnetic field produced by the current carrying solenoid depends on किस चीज के ऊपर डिपेंड करेगी. फर्स्टली, नंबर ऑफ टर्न्स इन द सोलेनॉइड. ओके, जितने ज्यादा टर्न्स होंगे उतना ज्यादा सोलेनॉइड कैसे होगा, मैग्नेटिज्म प्रोड्यूस करेगा. द स्ट्रेंथ ऑफ करेंट, जितना ज्यादा करेंट होगा उतना ज्यादा मैग्नेटिक फील्ड स्ट्रॉन्गर प्रोड्यूस्ड होगा. नेक्स्ट, द नेचर ऑफ कोर मटेरियल, कि वो किससे बना हुआ है, वो रॉड, वो सोलेनॉइड किससे बनी हुई है. द यूज ऑफ सॉफ्ट आयरन रॉड एज अ कोर in a solenoid produce the strongest magnetism. Okay, next point. Force of the current carrying conductor field in a magnetic field. We have learned that an electric current flowing through a conductor produced a magnetic field. The field so produced exert a force on a magnet placed in the vicinity of a conductor. French scientist André-Marie Ampère suggested that the magnet must also exert an equal and opposite force on the current carrying conductor. The force due to a magnetic field acting on a current carrying conductor can be demonstrated through the following activity. Figure number 12.2. A current carrying rod AB experiences a force perpendicular on its length and the magnetic field. Support for the magnet is not shown here for simplicity. The displacement of the rod in the above activity suggests that a force is exerted on the current carrying aluminum rod when it is placed in a magnetic field. It also suggests that the direction of force is also reversed when the direction of the current through the conductor is reversed. Now, change the direction of field of vertically downward by interchanging the two poles of magnet It is once again observed that the direction of force acting on the current carrying rod gets reversed. It shows that the direction of the force on the conductor depends upon the direction of current and the direction of the magnetic field. Experiments have shown that the displacement of the rod, experiment क्या show कर रहा है, the displacement of rod is largest or the magnitude of the force is the highest when the direction of current is at right angle. Right angles means perpendicular to the direction of magnetic field. In such a condition, we can use a simple rule to find a direction of force on a conductor. Okay. Since the direction of motion of the wire represents the direction of force acting on it, we can say the direction of force acting on a current carrying wire placed in a magnetic field is perpendicular to the direction of current and the perpendicular to the direction of the magnetic field. Okay. In the other words, we can say that the current, the magnetic field and the force are the right angles on the other. We should be noted that the maximum force is exerted on the current carrying conductor only when it is perpendicular to the direction of magnetic field. No force acts on the current carrying conductor. कब नहीं होता? No force acts on a current carrying conductor when it is parallel to the magnetic field. When it is parallel to the magnetic field. Next आया आपका Fleming's left hand rule. Hold the forefinger, the center finger and thumb of your left hand at right angle of one another, just shown in figure number 12.13. Adjust your hand in such a way that the forefinger points in the direction of magnetic field and the center finger point in the direction of current. Then the direction in which thumb points gives the direction of force acting on the conductor. Okay. We considered the direction of the current and that of the magnetic field perpendicular to each other and found that the force is perpendicular to both of them. Okay. Devices that use current carrying conductors and magnetic fields include electric motors, electric generator, loudspeakers, microphones and measuring instruments. Magnetism in medicine. An electric current always produces a magnetic field. Even weak ion currents that travel along the nerve cells in our body produce magnetic fields. When we touch something, our nerves carry an electric impulse to the muscles we need to use. This impulse produces a temporary magnetic field. These fields are very weak and are about 1 billion of the Earth's magnetic field. Two main organs in the human body where the magnetic field produced is significant are the heart and the brain. The magnetic field inside the body forms the basis to obtaining the images of different body parts. This is due using a technique called magnetic resonance imaging MRI. Analysis of these images helps in the medical diagnosis. Magnetism has thus got important uses in medicine. Domestic electric circuit. In our home, we receive supply of electric power through a main supply, also called mains, either supported through overhead electric poles or by underground cables. One of the wires in this supply, usually with red insulation cover, is called live wire or positive. Red insulation cover is called live wire or positive. Another wire with black insulation is called neutral wire or negative. In our country, the potential difference between the two is 220 volt. Potential difference between the two is 220 volt. At the meter board in the house, these wires passes into an electricity meter through a main fuse. Through the main switch, they are connected to the line wires in the house. These wires supply electricity to separate circuits within the house. Often, two separate circuits are used, one of 15 ampere current rating for appliances with higher power rating such as geyser, air cooler, etc. The other circuit is of 5 ampere current rating for bulbs, fan, etc. The earth wire, which has insulation of green color, is usually connected to a metal plate deep in the earth near the house. This is used as a safety measure. In order to distinguish between the live wire, neutral wire, and the earth wire. The wire having red plastic covering is made live wire. The wire having black plastic covering is made neutral wire. The wire having green plastic covering is made earth wire. Okay. For example, electric press, toaster, table fan, refrigerator, etc. The metallic body is connected to the earth wire, which provides a low resistance conducting path for the current. ओके मेटलिक बॉडी किससे कनेक्टेड होती है? अर्थ वायर से. और ये क्या प्रोवाइड कराती है? अ लो पावर रेजिस्टेंस कंडक्टिंग पाथ फॉर द करंट. Thus, it ensure that any leakage of current to the metallic body of the appliances keeps its potential to that the earth, and the user may not get the severe electric shock. ओके इस चीज को आपको याद रखना है. नेक्स्ट, one of the common domestic circuits is shown here in figure number 12.15. In each separate circuit, different appliances can be connected across the live and neutral wires. Each appliance has a separate switch to on or off the flow of current through it. In order that each appliance has equal potential difference, they are connected parallel to each other. Okay, parallel to each other. Why it is parallel to each other? What is the advantage of parallel? Advantage of parallel circuit is that the same voltage of the main lines is available for all the electrical appliances. Okay. And another advantage parallel connection is that if one of the appliances is switched off or get fused, there is no effect on the other appliances and they keep on operated. Okay. Electric fuse. Electric fuse is an important component of all domestic circuit. We have already studied the principle of working of a fuse in the previous chapter. A fuse in a current prevents damage to the appliances and the circuit due to overloading. Okay, firstly, what is electric fuse? Electric fuse कहाँ यूज़ किया जाता है? Firstly, ये क्वेश्चन है. Electric wires used in a domestic wires are made up of copper metal because इलेक्ट्रिक फ्यूज में हम इलेक्ट्रिक वायर को यूज करते हैं. इलेक्ट्रिक वायर क्यों करते हैं? द इलेक्ट्रिक वायर यूज्ड इन डोमेस्टिक वायरिंग आर मेड अप ऑफ कॉपर मेटल because copper is a good conductor of electricity having very low resistance. Why we are choosing copper wire? We are choosing copper wire because it is a good conductor of electricity having very low resistance. Okay. Overloading a fuse in a circuit prevents damage to the appliances and the circuit due to overloading. Overloading can occur when the live wire and neutral wire come into direct connect. Overloading कब होती है? When the live wire and neutral wire come into direct contact. This occurs when the insulation of wire is damaged or there is a fault in the appliance. In such a situation, the current in a circuit abruptly increase. This is a short circuit. The use of electric fuse prevents the electric circuit and the appliance when a possible damage by stopping the flow of unduly high electric current. The Joule heating that takes place in the fuse melts it to break the electric circuit. Overloading can also occur due to an accidental hike in the supply voltage. Sometimes overloading is caused by connecting to many appliances to a single socket. When a fuse क्या होता है? मैंने पहले बोला था, पर फ्यूज की डिफाइन मैंने नहीं बताई थी. A fuse is a safety device having a short length of a thin tin-plated copper wire having low melting point which melts and breaks the circuit if the current exceeds a safe value. Okay. An electric fuse works on the heating effect of current. Another thing, a fuse wire is connected in series in the electric circuit. Series. Okay. The fuse wire must have proper thickness which depends on the maximum current which the household wiring can safely carry. Okay. A pure copper wire cannot be used as a fuse wire. Why? because it has a high melting point due to which it will not melt easily when a short circuit take place. Fuse are also used to protect the individual domestic electrical appliances from damage which may be caused due to excessive current flow through them.